Hello everyone. We're going to continue on forecasting. This video will be focusing on providing some examples. The first example that we need to take about the naive forecasting. This is one of the simplest and easiest way to forecast. So for example, if demand for a product last week was 20 cases, so the forecast for this week will be also 20 cases. So also with the seasonal variation, the forecast for this season is equal to the value of the series last season. So for example, the forecast for demand for turkeys this Thanksgiving season is equal to demand for turkey last Thanksgiving. Another example, the forecast for the number of chicks cashed in at a bank on the first day of the month next month is equal to the number of chicks cashed on the first day of this month. So again, the naive forecasting, we use the past data to forecast what is the demand for the future need. Now moving into the another forecasting technique called the moving average. So in this example, compute 3-period moving average forecast giving demand for shopping carts for the last 5 periods. So we have period 1, 2, 3, 4, 5, demand 42, 40, 43, 40, and 41. So they're saying the last or the 3-period moving average. So we select the last, the most recent demand. So we say 43 plus 40 plus 41, divide that by 3. That would be 41.33. However, if the actual demand on period 6 turned to be 38, not 41. So we ignore what we forecasted and we go with the new actual data. So the moving average for the moving average forecast for period 7 would be starting from 4. That would be 40, 41 plus the actual demand in period 6, which is turned to be 38. So again, you go back 3 periods and then you take the average to find out what would be the forecast. All right, now moving into the weighted moving average, that's another excellent forecasting technique. Giving the following demand data, compute a weighted average forecast using a weight of 0.4 for the most recent. So they're saying, give me more weight on the most recent period, and then 0.3 for the next most recent, and 0.2 for the next, and 0.1 for the next. So we start from the bottom, and then 40, 30, 20, and 10%. All right, if the actual demand for period 6, that's for part B. Let's finish part A. If you look into the weighting average, so if you added 0.4 plus 0.3 plus 0.2 plus 0.1, that will give you a 1%, a 100%. So that will give you a more weight on more recent demand. So we say starting from the bottom, which is 40% on the most recent one. So I'm going to start from period 5. So you'll see 41 right there. 41 right there. We multiplied that by 0.4 plus 40 times 0.3 plus 43 times 0.2 plus 40 times 0.1. The forecast would be 41 for period 6. Now continue with part B. If the actual demand for period 6 is 39, so we calculated to be 41, but the actual was 39. Forecast demand for period 7, we need to do the forecasting for period 7 based on the same weight as we did for part A. So we're going to start from the bottom, which is the 39 times 40. So 39, this is what the actual demand for period 6. So 39 times 40 or 0.4 plus 41 times 0.3, then 40 times 0.2 plus 43 times 0.1. So what we're doing basically, we're giving a weight for the last 1, 2, 3, 4 periods. So the last 4 periods, we take them and we find out what would be the forecast uh, for the new month or the new period. All right, now moving into a more complicated forecasting technique, which is called the symbol linear regression or the linear regression. Cell phone sales for California-based firm over the last 10 weeks. So we have a forecasting for, that's the actual sales for the last 10 weeks. Plot data and visually check to see if the linear trend line would be appropriate, then to determine the equation of the trend line and predict the sales for week 11 and 12. All right, so what I'm going to do, I'm going to share my Excel screen here in just a second. So we need to use Excel for this question. Right, so that would be this example right here. So we have the last 10 weeks or 10 periods, as you see here, from 1 to 10, and these are 700, 724, 720, etc. And now what I want to do as well, just to do the forecast. So what I want to do is to look into the forecast. Okay, so before we do this, so I'm going to delete this here. So this is what we get. So we created the trend. Basically, we will see just only the trend plotting the 1 period. That would be 700, as you see right there. Period 2 would be 724, etc. Now, what I want to do, I want to check the trend. And if you go to right here, double click on the chart, and this will open chart design. Go to add element, go all the way to trend line, and click on it linear. So that linear will tell you what would be the forecasting based on forecasting. Let's go also one more linear forecast. So let's select a linear forecast. That's what we want. So the linear forecast, not the actual. So I'm going to delete this actual here. Start one more time. Okay, let's select the linear forecast. So this is what we're looking for. That's the actual, for some reason. One more time. So that would be the linear forecast. And then what we also could do as well, we could add the equation here. Just a second. We need to find. All right, we're going to go to more trends. So we're going to do a linear. We'll do the down here, display the equation. So that's the equation to forecast for the forecast here, and display the R square. And now what we have to, we looked into the forecast. I'm not sure why it's labeled as an actual, but it's not actual. It is a forecast. I'm gonna just try one more time, see why this is saying actual. Double click. This is trend line and linear forecast. So this is the linear forecast. As you see, it's listed there. But it's still maybe because of this right here, the label of this data is called actual. This is why you see the actual. But that's the equation that we're looking for. This is the trend, the linear equation. As you see, this is y equal to 7.5091 times x plus 699. And this is the slope basically. And this is the variable that will predict the future trends. So if we're going to predict this based on this data, so we need to predict the next following periods based on this data. So we use this equation, which is 7.5091 times x. X would be the time of period, so that's times 1 plus the 699.4. That what will give you the forecast here as well. Do the same thing, just change the period, the same equation, and for the r square, that will give you how this model that we created will be accurate. So basically, we have a model of the accuracy of this model to be 94% here. Okay, so one more thing also, what I want to do is the correlation, to find the correlation, if it's positive correlation or negative correlation, and remember that it's between 1 and -1, so that we have a 0.96, so it is a positive, strong positive correlation between the forecast and the actual demand. So that's about I hope this is helpful. Let's see if there's another example that we could take. All right, going back to here. Okay, we're done with this one. So we forecasted the equation. This is what we got through Excel, just using the trend line. And then we forecasted for 11 and 12. Let's go back just one more step here, just to make sure that we addressed all the answers. So 11 and 12, it's based on this equation. And we calculated to be 11 and 9 to be 782 and 789.5. 7 point. And the same thing as you see here, 782 and 789.5. And we did display the chart, which is similar to this one here. All right, now what we're going to do, we're going to move on to the next example, which is combining the seasonality index with linear regression. So we have a coffee shop owner wants to estimate demand for the next 2 quarters for hot chocolate. Sales data consists of trend and seasonality at the same time. And they give us the seasonal index. So for season 1 is 1.2, season 2 is 1.1, 0.75, and 0.95. Use this information to deseasonalize sales for quarter 1 to 8. So we have quarter 1, 2, 3, 4, 5, 6, 7, 8, and we give us the quarters here: 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. And these are the sales. So first of all, what we need to do, we need to deseasonalize the sales. So I'm going to share my Excel here. Let's go here. Okay, so these are the seasonal index that we have, and then what we need to do, we have to deseasonalize the actual demand. So this is the actual demand. We need to remove the impact of the season. So by dividing the actual demand by the seasonal index, that will give you the actual the actual demand without the impact of the season. The same thing for all of these periods. Now, so this is what we did. This is for part A. Part A, we need to deseasonalize the sales from 1 to 8. So this is the part right here. You take the actual divided by the seasonal index. Now for the trend, part B, using the appropriate value of quarter relatives and the equation. So we have this equation, 124 plus 7.5 times T. We'll estimate the demand for period 9 and 10. So the first thing what we need to do, we need to use this equation. So I built this equation into Excel, 124 plus 7.5 times the period 1 pair, and then move on with this 2, 3, same equation, just you change the period to find out what would be the trend based on this linear equation that we have. And now we need to consider the index for each of these periods, and we have the period, the index to be 1.2, 1.1, and these basically from here, taken from here. And now this would be what the forecast for each of these seasons. So that would be 159. This is coming from 131.5 times the index that we have it here. And that will give you what would be the demand for 9 and 10 based on the both combination of the seasonal index and the linear regression. All right. I hope this is helpful. Please let me know if you have any question. There's still one more video. We need to talk about the accuracy of the forecasting, and we need to share with you a few more examples on how you could estimate the accuracy of your forecast model. I'll see you in another video.